Hello everyone. So today we are going to learn the course problem solving using C. So we are going to explore advanced structures in C program. So which are essential for organizing complex data efficiently. So what first we should know what is structures. Structures allows us to group different types of data under one name. An advanced concept extends this capability further. So by end of this module, we are going to understand about how to work with nested structures, how to use arrays of structures, pass structures to functions, utilize structure pointers. So we have already discussed arrays and structures in our previous videos. Okay, so now let's discuss about the differences between the structure and arrays. So in C program, both arrays and structures are used to store data, but they serve different purposes. An array stores multiple values of the same type. For example, an array can store a list of integers or characters, but all elements must be homogeneous, which means of same data type. But a structure, on other hand, can store multiple values of different data types under one name. For example, a student structure can store an integer roll number, a character name, a float percentage, etc. So what are the key differences means? So arrays are homogeneous while structures are heterogeneous. Arrays uses indexing, structures use member access. Structures are more flexible for real world data modeling. So next, in the structures only we have a concept called nested structures. So what is this nested structures? A nested structure is a structure that contains another structure as one of its members. So this is very useful when a complex entity is made up of smaller related components. For example, we can take an employee may have joining date, and the date itself has a day, month and year components. Okay, so there are two ways to define nested structures in C: by using separate structures or by using embedded structures. We'll go first with the separate structure. So in this method, we define the inner structure separately and then include it as a member inside another structure. For example, we can take a date structure contains day, month and year. An employee structure contains ID, name and a date structure. So this approach improves modularity because the date structure can be reused in multiple places. Next, coming with the next one, embedded structure. So in this method, the inner structure is defined inside the outer structure itself. This is useful when the inner structure is only relevant within the context of the outer structure and does not need to be reused elsewhere. For example, the date structure is defined inside the employee structure. So this approach improves encapsulation and keeps related definitions together. Next, how to access nested structure members. To access members of a nested structure, we use the dot operator in a hierarchical manner. Here the syntax is outer structure dot inner structure dot member. For example, E1 dot DOZ dot DD access the day, E1 dot DOZ dot MM access the month, E1 dot DOJ dot YYYY access the year. So this allows precise access to deeply the nested text. Arrays of structures. So when dealing with multiple records, instead of declaring multiple structure variables, we can use an array of structure. So this allows us to store multiple instances of a structure in a single variable. For example, a student database can store using an array of student structures. This approach is efficient and scalable for handling large data sets. We all know the dataset contains a large amount of data. So in the given example, that is structured with array. So this example demonstrates how to use an array of structures to store data of multiple students. So here the steps explain. So first we need to define a structure student with roll number and name. So after declaring an array, that is st of 5, to store 5 student records, then we are going to use a loop to input the data. After that, so use another loop to display the data. So in this example, so we can highlight use of loops with structures, input and output operations, organized data storage. Next, we have concept called structures and functions. So structures can be passed to functions just like normal variables. Okay, in this there are three ways to pass structures to function. First, by using the value, by using address, which is also known as reference. Next, using global structure variables. So each method has different implications for memory usage and data modifications. So passing structure by value. So in this method, we can see a copy of structure is passed to the function. Key points. So changes made inside the function that do not affect the original structure requires extra memory to create a copy. So in this example, it shows a student structure initialized in main function. So we all know that in the main function only we are writing the main code. So pass it to a function, values printed inside the function. Next we can see passing structure by address. So in this method, the memory address of the structure is passed to the function. So in this also we are having some key advantages. The first one is no extra memory is required. Next, changes made inside the function affect the original structure. Okay, once you made any changes in the function, it directly affect the original structure. And then third one is the more efficient for large structures. So here the pointers are used and the members are accessed using the arrow operator. We can see the example by passing array. So in this example, it demonstrates passing a structure using pointers. So here the steps are, first we need to define a structure. After defining the structure, we need to pass its address using AND operator. Okay. Next, after that, receive it using a pointer. Then access members using the arrow operator. We all know that. So structure members can be accessed by using either arrow operator or dot operator. So this method is used widely in real world programming due to its efficiency. Next, passing structures through pointers. So we all know that what is a pointer? Pointer is a which is used to store address of another variable. So a structure pointer stores the address of a structure. So this allows direct manipulation of structured data without copying. So in this we'll have so many benefits. So we can say some examples. Efficient memory usage, faster execution, direct access to original data. Let's see the structure pointer example. Okay, this example shows declaring a structure variable, creating a pointer to it, accessing members using pointer member. So this demonstrates how pointer specifying working with structures, especially in large programs.